Okay, so welcome back. I realized after I stopped the first video that we never filled in this part. So we are going to go ahead and do that now because we are going to move on to the factoring them to find our answers. All right, so when the left side of standard form is factorable, so when it's equal to 0, it is factorable. You can solve the equations using the zero product property. Zero product property. All right, so the key part of this is to note that when it is equal to 0. So in order to do this, the right side must be 0. All right, so let's move on to the zero product property. So that is right here. All right. So if A and B are expressions, A times B equals 0, then A equals 0 or B equals 0. So I'm going to show you what this means. First off, though, our equation is not equal to 0. So we need to set it equal to 0. So that just means we need to move this 45 to the other side. So how do we do that? How do we make it 0? We subtract itself. So now we have x squared minus 4x minus 45 equals 0. All right, so here's one of those things that you are supposed to remember from previous years, factoring. All right, so if you struggle at this part, there will be a Khan Academy video. Please go try it, go practice it. Okay, so there's a couple of ways you can do this. You can think back to factor trees. I like to do a method, it's called, I think they call it like a diamond method. I'm not really sure, but essentially what you're doing is you're setting it up with multiplying, so I'll write the words out, but in the future I won't, and adding. All right, so what are we multiplying? What are we adding? So we're essentially looking for two numbers that when you multiply them, you get negative 45. But when you add them, you get negative 4. So think about some numbers that you could multiply to get negative 45 and add. So here's one clue. Because the adding is negative and the product is negative, one of these factors must be negative in order for this to happen. And then because this one is negative, that means it's the bigger factor. So let's think of some numbers that we could multiply. 45, I'm going to move over to here. So 45, think of some numbers that you could multiply together to get 45. All right, so 1 and 45. Well, that's too big because our goal is to get negative 4. All right, and then we have 2 doesn't work, 3 times 15. Well, remember, because we need negative 45, we already said our bigger number would need to be negative. So if we add those together, we would get negative 12. So that doesn't work. We need negative 4. So does 4 go into this? No. What about 5? So 5 times 9. So remember, our 9 needs to be negative. Well, if I add 5 and 9 together, so if I say 5 plus negative 9, then I get negative 4. So that's my two factors. So these are my two factors, 5 and negative 9. So that's what this, so do you have to, whoops, it's the bigger one, not the smaller one, lady. So you don't have to use this method. It's just kind of like an organization method to think about which two numbers. So essentially, if you want to think about it this way, you're looking at, let me get a different color. You're looking at two numbers that you can multiply to get negative 4, but when you add, I meant multiply to get negative 45, but when you add them, you get negative 4. So I'm just putting them in an organization method here. You do not have to do it this way. You can think about it. So now that we have those two, what do we do? Well, we're going to set them up into two parentheses equal to 0. We need this. Well, what could you multiply to itself to get x squared? X. X times x gives us x squared. So we're kind of like doing the reverse box method is how I could think about. Or if you like the FOIL method, we're doing the reverse FOIL method. So then we pull in our two factors that we came up with. And how do you check yourself before you wreck yourself? You do, what's negative 9 times positive 5? It is negative 45. What is negative 9 plus 5? It is negative 4. So we're good. So how do we find the zeros? How do we find that solution? Well, now we're going to take each one of these and we're going to set each one equal to 0. Because remember, in order to get 0, one of these had to be 0 in order for it to equal 0. Because the only way to get 0 as your answer is if you multiply by 0. So we're going to say, well, what if x minus 9 was the one that was 0? What if x plus 5 is the one that's 0? All right, so what we do then is we solve them. So what would you do? You would add 9 to both sides, right? Just like you would solve a one-step equation. X equals 9. Some of these you're going to come to realize it's just the opposite. Can you skip this step of showing it? You sure can if you understand why. And we have x equals negative 5. So these are the zeros. These are your solutions. All right, so the solutions, just so you remember, are x equals negative 5 and x equals 9. So those are your two solutions. All right, so now I want you to try this self-assessment question. I want you to pause the video. This should be done in your journal. And come back when you think you have it. So hopefully you got to this part. Remember, you needed to make it equal to 0. All right. Why did they do this to us? I just realized that this one has an a value where the other one didn't. I'm sorry that I did not realize this ahead of time. All right, so if you weren't able to factor it, it is because they were not nice to us. So in this situation, we have an a value. So because we have an a value, we have to multiply those two together. Yes, you learned this in Algebra 1. So we have to multiply 3 times negative 2. And when we do that, we get negative 6. So this is your new multiplication number. So basically what we need is we need two numbers that when you multiply them, you get negative 6, but when you add them, you get negative 5. All right, so we need two numbers that when you multiply, you get negative 6, but when you add, you get negative 5. Now, remember, because the multiplication one is negative and the addition one is negative, that means one of these factors must be negative and it must be the bigger factor. There's not very many things that go with 6. So if we think about the factor tree for 6, we have 6 times 1. Well, we said the bigger number has to be negative. So if you take negative 6 and you add 1, do you get negative 5? You do. So this would be negative 6 and 1. I want to show you why negative, because some of y'all might say, well, 3 times 2 is 6 and 3 plus 2 is 5. But remember, your bigger number is negative, not both, or this would be positive. So negative 3 plus 2 would give us negative 1, so that doesn't work. All right, so now, remember before, we were able to make two parentheses and we could just say x and x, right? Well, this time we can't because there is an a value. All right, so we're going to do reverse box method. If you come up with another way to do this that you like, you are welcome to do it that way. This is just the easiest way that I have found to explain it. All right, so essentially what we're going to do, let me erase this because I was just demonstrating, is we have to break this up. All right, we got to break this up. So we're breaking this up using these factors. So negative 6x plus 1x. All right, and then we have our minus 2 and 3x squared. So if you remember doing the FOIL method, we're kind of going backwards because this would be your answer. This is what you would have had before. So you have two things. You can use the box method where what you would do is you would put it in here like this. I'll show you both ways. You can choose which one you like. Does it matter where you put x and negative 6x? It does not. So if you put negative 6x here, it's just these will be reversed. All right. So now what we're doing is we're looking down. What does 3x squared and x have in common? They have an x in common, right? We're looking down again. Well, these both have a negative in common because they're both negative. And what factor does 6 and 2 have in common? A 2. They both can be divided by 2. All right, so that is going to be one of our factors. I'm going to wait because I'm going to show you another method before I write that out. All right, so now we're looking at it this way. So what does it have in common this way? So they have a 3 in common, right, because both of those numbers can be divided by 3. They also have an x in common. So we have a 3 and an x. And if we look this way, do they have anything in common? No, that's okay. They can both be multiplied by 1. So basically our factors are x minus 2 times 3x plus 1. Maybe you're like, Ms. Gill, that's too much. That's okay. You can do it another way. So the other way you can look at it is you can separate these two. Okay? And you're basically doing the same thing here, but it looks a little different. So what do these two numbers have in common? We know they have a 3 and they have an x. So what is left? So 3x times what would give us x squared? That would be x. 3x times what would give us negative 6? That would be minus 2. So here's the thing with this method though. Whatever you get here, you have to get again. Okay? So what I mean is we're going to put a plus sign here. We need to find a factor here, but this has to be x minus 2. These two parentheses have to be exactly the same. All right, so if you factor out from here, you would only be able to factor out a 1 and to make this the same as that one. Okay, so what you do, you bring these two down, so you get 3x plus 1, and then this is the same, so you just bring that down. So this is one of them, the other one is x minus 2. Notice these are the same values, so doing it the box method, we got x minus 2, 3x plus 1. So these are the same ways. So again, I apologize that they gave us a hard one here. I did not realize that at all. So hopefully we can always practice some more in class as well. Or if you want to talk about one like this, just let me know. All right, going to come back with graphing on another video.